So Laplace transform of convolution. And you'll know why we need convolution from this Laplace transform. Okay? So Laplace transform of f star g, okay, that's f of s times g of s. Or it's Laplace transform of f times Laplace transform of g. This is really important, okay? They are really multiplication in S domain. Okay? Multiplication in S domain means convolution in T domain. That's that's the importance of this convolution. We need multiplication operation in S domain, right? And it happens many times. It always happens. Multiplication of S functions in S domain, then that's simply convolution in T domain. Okay? So we knew that the plus operation in S domain, right? The partial fraction, something over S plus something S, right? So that's the plus operation, and we have exponential multiplication. If we multiply exponential function in S domain, that's time shift in time domain, right? And if there's a multiplication in S domain, that means convolution in time domain. Okay? So this is important, So I'm going to give you one example, all right, of how you use the convolution, Laplace transform of convolution, okay? So let's say a given function, h of s, is 2 times omega s over s square plus omega square and square of this whole term. You can decompose this into the multiplication like this. 2 times omega over s square plus omega square times s over s square plus omega square. Correct? You can decompose a big complicated function into a more smaller form, right? Primitive form. Then you could do the inverse Laplace transform of big H, and the inverse of, and 2 comes out, okay, 2 times. You can take the 2 out immediately, right? 2 times inverse Laplace transform of omega over s square plus omega square times s over s square plus omega square. Okay? And the each one is, this is what? Sine omega t, right? This is cosine omega t. Then what? So h of t is 2 times sine omega t star cosine omega t. Y double prime plus 2 times y prime plus 2y is sine omega t. Okay, y initial conditions are 0. Okay, so since the initial conditions are all 0, so s squared plus 2s plus 2 times big Y is sine is omega sine s squared plus omega square. Okay, so Y is omega over s squared plus omega square times 1 over s plus 1 square plus 1. Okay? All right. So Y is inverse Laplace transform of Y, which is inverse Laplace transform of s squared plus omega square times 1 over s plus 1 square plus 1. Okay, so we are using the convolution. So that's sine omega t convolute e to the minus t times sine t. So y double prime plus 3y prime plus 2y is r of t. Okay, this r of t is 1, okay, 0 otherwise. And all the initial conditions are 0.